Hi, everyone, and welcome to Foundry Virtual Events. My name is Joyce, your marketing host for today. Just to let you know, today's webinar is recorded and will be available as on demand as soon as the session finishes. So make sure you stay back. And if you want to share with anyone, you can just use that link and it will be available on demand. I'm here today with a special guest, Vladislav Akhtyrskiy, also known as Vlad, based in Vancouver. Vlad, thank you so much for joining us so early in the morning as well, and for sharing your insights in machine learning, and really looking forward to having you in this webinar.
Hello, thank you.
I would also like to welcome my two colleagues from Foundry, David Nolan, Product Manager from Compositing and Finishing, and Ben Kent, Research Engineer Manager. So thank you both for joining me today to co-host today's webinar, and looking forward to having another webinar with you both.
Great to be here, thanks.
All right, so before we dive into the webinar, I just wanted to share a couple of updates with you guys. So we have over 60 webinars available on demand, so you can view these on our dedicated Livestorm page or our Foundry events page as well. I'm also really thrilled to announce the launch of Foundry Live, which we've just done a couple of days ago, a series of virtual events where all of our product managers come together from all of our products, sharing what's new, what's coming, and what's coming up for their roadmaps as well for each of the software. This will be happening throughout the week of September the 21st to the 29th, and I'll make sure to drop the registration link for the Foundry Live shortly in the chat as well. For more information on Foundry Live or virtual events, or you want to participate in virtual events in the future, just send us an email on virtual.events@foundry.com. We have a dedicated page for learning and training materials in case you are looking to brush up your skills or to expand them. Make sure to pay a visit when you have a chance. We've got some really great content available on this page. We also have Victor Perez's Color Management Training Volume 1, which you can watch for free and learn as well. We also have a dedicated page for insights, sharing case studies, trends in the industry, and artist spotlights, sharing their journey throughout their careers and how they've enhanced their skills. Definitely make sure to shed an eye on this page as well. And of course, follow us on social media. We have a range of roles available here at Foundry if anyone is interested. They range from marketing to HR to products and engineering, etc. So for more information on the job spec, you can visit our dedicated Foundry careers page as well. And I'll make sure to drop all of these links in the chat so you can have a look at it later on. So our virtual events wouldn't be anywhere without the amazing studios, the partners, and the artists that we're working with. Thank you so much for sharing your stories, your projects, your insights in the industries. And I'm really, really looking forward to building many more stories in the near future with many more studios and artists as well. So I think some of you have already received this in your inbox, but just to let you know, we have just recently launched our Nuke annual survey, 2021 Nuke Future Survey. We would love to hear your feedback and thoughts. If you haven't had a chance to fill out the survey yet, make sure you do so now. And again, I will drop the link for the survey in the chat as well. So everyone who completes the survey will automatically enter into the prize draw to win a Production Collective license. And we'll make sure to be in touch with the lucky winner as well in the coming weeks. So make sure you fill out the survey. All right, that's enough talking for me. Let's dive into the webinar and unfold the future of VFX with machine learning and AI automation. So let's dive a little into what Ben has to share for machine learning automation here at Foundry.
Hi there, I'm Ben Kent, Research Engineering Manager at Foundry and the lead on the AI research team. And I'm going to tell you a little bit about what we're doing by way of machine learning automation at Foundry. I guess the first thing to talk about is what do we mean by automation? So according to one dictionary definition I found, automation means the use of machines and computers that can operate without needing human control. Well, in Foundry's AI research team, we really don't want to replace artists with machines. So when I talk about automation, I'm going to mean using machine learning to remove and speed up the boring, mundane and repetitive tasks that you don't really want to do, so you can concentrate on doing the fun, creative things that made you want to be an artist in the first place. Okay, so how are we actually doing that? Well, the first tool I'll talk about is Copycat, which we released in Nuke 13. Apologies for those of you who've heard my spiel before, but in case there's anyone listening who isn't familiar with Copycat, I'll quickly tell you what it does. Copycat is a Nuke X plugin that allows a user to train a neural network specific to the sequence or set of sequences they're working on. The way that works is you give the plugin just a small set of before and after images that demonstrate an effect, and it learns to replicate the transformation from one to the other and stores that as a neural network in a cat file. You then load that cat file in the inference node where it can be applied to the rest of your sequence. So in terms of automation, you set up a script to demonstrate the effect, and then it'll take care of the tedious stuff to reapply it to the other frames. And that can be any image-to-image effect. It's really down to the artist's imagination. There are some familiar use cases like garbage matting and beauty work, and if you've not seen these, there are some great tutorials on the Foundry learning page that show you how to do them. We've also seen some completely different examples, like in our recent Copycat in the Wild webinar where Mads Hagbarth Damsbo showed how to use Copycat to automatically combine an actor's lip movements from one take and their overall performance from another into a single shot. There's also this great marker removal example from Tiago Porto, where he's eliminated hours of tedious paint and tracking work by manually removing the markers on just a few frames and then using Copycat and inference to do the rest of the sequence. For Nuke 13.1, we're also making some exciting extensions to the inference node to allow users to load third-party PyTorch models natively inside Nuke. This will massively expand the number of machine learning models artists have access to in Nuke, whether that's networks they've trained themselves in Python PyTorch, models created by in-house research teams, or even third-party models downloaded from GitHub. The scope for automation is huge, and it's not limited to models Foundry creates. For example, here I'm showing you a third-party network from GitHub running natively inside Nuke. This is a network that can segment images into different semantic categories. So here we're showing cars, buildings, people, and you can imagine this will be great for knocking up any number of effects. But this really is just one example of the many networks that this update will make available to you. Alongside this, you may have seen that we've been actively looking into how to use machine learning to accelerate Roto as part of the Innovate UK funded Smart Roto project alongside Double Negative and the University of Bath. Now I say accelerate Roto because, again, our view of machine learning in Roto is that it would be to assist and not replace the artist. The artist would still set up shapes, but the machine learning would help speed up the Roto process by cleverly automating intermediate keyframes, reducing the number the user needs to set manually. Our thinking is that Roto is such a painstaking, laborious, and yet ubiquitous task that even if we could reduce the number of keyframes by 50, just 25%, it'd still be a massive win. Now the funded project's just come to an end, but we view speeding up Roto as one of the holy grails of visual effects, so something we hope to carry on looking into. And we've definitely learned a lot over the course of the project. One thing being that real-world Roto is really hard, and that artists are definitely going to stay part of the picture. And into the future, we have a number of machine learning and automation ideas we're considering looking into. So it'd be fantastic if you could all let us know which ones you think would be the most valuable by filling in the 2021 Nuke Futures survey. And I think Joyce is going to post a link to that in the chat later. Speaking of Joyce, back over to you.
Awesome. Thank you so much, Ben, for such a great insight. Now, before we dissect this topic a little bit more into detail, let's hear from Vlad why we should leave some of the routines and resources to machine learning.
Hi everyone, this is Vlad from Techdashville. In this video I want to show you what Techdashway is about. Before I go to details, let me just execute a few shots automatically. To do so, I'm bringing the tool which called Techdashway Jobber. And what it does, it runs everything what is inside, it's just a read nodes. based on this template and save output with alpha channel and save Nuke scripts with the results where the markers will be removed and green screen will be keyed out. You can use any kind of outputs here. You just can specify the file type and codecs, whatever relative to the output. And here you need just to specify the folder where you want to output it. And if you want to keep a color space from the input nodes, you can just leave as is. If you want to force it to something what's been set up in the right node, it will just force to that. You can run it in Nuke, or you can just run it in command line. That's what I'm going to do, because I want to use this Nuke session to show you the rest of the tools. So to execute it, I just need to select the template and press Start button. It's already created for me the bat file. In case of Windows and other operation systems, I mean Linux, Mac OS, it will be a such file to execute it, and it will put appropriate paths to your software. Okay, so whilst it's running, it's up and running, so we will see that when this thing is gone, that means the job is done. Let's have a look at all the tools individually. So what I did here is, and as I said, this coming with package, I specify the order of executions for markers, 0 for another hacky way of using care, it's a 1, and last one predict will be just order number 2, so 0, 1, 2. But you can put whatever numbers you want as long as you keep the order. And this template is basically driven by this node, which looks for any existing Techdashway tools and collecting the order and placing them in order, how to run them, and etc. Okay, tools. vAlpha Predict. By the way, we have quite a lot of information on our YouTube channel, specific detailed video about vAlpha Predict as well. For example, this is our default algorithm which pulls decay, but I want to keep more details here. Our key area just has 4 sliders. Type is either for green or blue screen, so you can press ignore and it won't be changing automatically if you're running everything on a blue screen or green screen. So why would you worry about that? So as you can see, we can adjust all the values and settings here inside Nuke. And machine learning helping us to bring these values in a correct way. So sometimes our algorithm doesn't know your material, or you want to, for example, make a softer key here. You can use training. And training works in a way that we have a one-shot training. You can put many shots in the set. I usually recommend to run on like this automatically, more or less on the same kind of looking shots, but you can train it for like comprehensive models as well. So what we need to do is we need to set up the values enough, like to see all the details, what we want to keep as much as we can if we want to run it in one go as it's like now. Okay, and multiply should be always above 1. But as you can see, we're comparing our default result and the new one, which we will be just called model 01, and create train set and start training. Training takes around like a minute probably most of the time. You can check status of the training by just pressing check status button or updating the list in vAlpha Predict, and as long as model is there, you will be able to use it. So let me just click once again. No, it's not ready yet. Okay, whilst it's just preparing, let me show you something about our markers. So marker detection tool is simply detecting markers, and you will see results on how it runs. I will run it on this 4.6K sequence to not only identify markers, but to actually do the tracking automatically. We just recently connected technologies and put things together to make it work. We need some improvements, and we know it, but it's quite impressive what we can get automatically. Okay, I'm coming back to the our trainer. So whilst our markers are getting detected, let's compare our two results. Model 01, what we get here, versus our default algorithm. So as you can see, it tries to kind of be close to the training shot and brings you details. And you can apply this knowledge on similar looking shots. On some it might not just give you what you want because the values are too dissimilar. But on some similar looking shots, it can give you a little bit more detail. So you just need to work with the settings to adjust them and apply them to more shots. So those kind of like values here are fairly similar. And if you're working on the same sequence, you can procedurally apply this changes to the rest of the shots. Let's have a look at our tracker. So I think it should be done by now. What is our tracker is doing? It's actually generated tracks. Let me just over it like this so we can review things here. Tracker, track number 1. Let's look at the track number 1 here. Well, as you can see, some of them, yeah, it's kind of like jumping around. At the same time, it's trying to follow. Let me just do input frame range. So it's trying to follow the identified markers and basically provide you the track, which you can use to put background in and do something else. So whilst I was showing you this stuff, our automatic work from this part being done. Let's have a look at what we have here. It's quite exciting. So that's done just under 5 minutes. Let's just have a look at the details when it's been created. 701, 656, 6 minutes. So as you can see, markers been removed, key been pulled. Some like yeah, there's sometimes, but it's a matter of time to make it work properly. Yeah, that's the shot we've been training on. As you can see, it's kind of like a little bit crunchy, but if we apply this model, we will get the new model we just created. We will get the better results. Same with this shot. Markers been removed and key being pulled. Let me show you another thing we're wrapping really soon. It's a ZDepth. By the way, you can go to our YouTube channel and see some of the showcases and examples of results of our tools. This is the shot I just took from my window, and that's what we kind of get in under less than a few seconds. What we can do with it, I mean, it's up to you what you can do with ZDepth. You can just animate defocuses or just do some color correction and depth hazing. I mean, this shot obviously not, it's too sunny for that, but still we can do this. And it's actually been generated in 4K. I'm just scaling it down so Nuke can process it in whilst I'm recording and do lots of other things. So as you can see, you can just rack focus, you can apply focus to something, or you can color correct through ZDepth. As I said on our YouTube channel, there is even more examples. Well, thank you very much for watching.
Thank you, Vlad, for sharing your experiences and insights here. Really, really good stuff. David, shall we dive into some of the preset questions that we've put together.
Yeah, that sounds great. Thanks, Joyce. Hello, everyone. We're going to be going into a conversation now, and then we'll do a question and answer session. So if you've got any questions for Vlad or Ben, please jump over to the questions tab and put your questions in, and we'll try and get through as many of those as we can towards the end of the session. But before we do that, I'm just going to start with maybe the question that all visual effects artists want to know about machine learning. It's obviously very early days in machine learning for VFX, but already we're seeing really quite impressive results. So what's the end game here? Is machine learning going to steal all of our jobs?
I don't think so. I honestly don't think so. I mean, there's, apart from routine, there's lots of creativity and ideas and things and stories we want to tell. I don't think so.
Yeah, I mean, I would agree. If you look at the general state of production today, I mean, with the pandemic, the streaming wars, it's kind of blurred the lines between theatrical content and TV. And now you've got the sort of effects which would have been on like these mega budget tentpole productions are now being put onto, episodic content where they're producing, 10 plus episodes a year. So there's this huge demand for VFX at the moment. And honestly, I can see it just getting more and more. And I think with machine learning, if we make visual effects faster, cheaper, I think people are just going to want more visual effects, and there's just going to be more jobs. And that's one aspect. The other thing I've been thinking is that, as new techniques and technology become available, there's also other markets that open up that you probably haven't even thought of before. And one of them that kind of was springing to mind was, animating actors' lips for dubbed performances, for, English films in foreign language territories. That's something no one would have even thought of, bothering to animate the lips before. It was unfeasible. Now maybe it would become a thing, all because machine learning makes it cheap enough and easy enough to do.
That's really interesting. So you don't think that machine learning will take our jobs, but it could allow us to do things that are currently impossible. Is that what you're saying?
If not impossible, yeah, unfeasible.
Unfeasible. So apart from the lip syncing, which is a really interesting idea I'd never thought of, can you think of any others like that?
Not off the top of my head. Otherwise, I'd be running off to start a new business. But no. But I'm sure smart people will come up with them.
Well, I think one example is actually a tool that we released in Nuke 13.0, which is the deblur tool.
Yeah. So, okay, generally, if we're talking about things, impossible things that machine learning does create, of course. Yeah, the deblurring is amazing to me because most of what we do in computer vision, I've always thought it's trying to replicate the human brain and what the human visual system. And, if you look at something like tracking, trackers are good, but as a human, I can always tell where the thing goes in an image. I might not do it as quickly as the computer, but I could probably do it just as well or better. But deblurring is amazing to me because, especially when there's text in images, it just recovers things that, as a human, you had no idea were there. And that's one of the things with machine learning that, it really does make the impossible possible. But if we're talking from a feasibility point of view, again, I don't know if people saw the Welcome to Chechnya. There's a lot of articles about that, but if you haven't seen it, it's a documentary that's coming out where they needed to hide the identities of some of the people in it. And traditionally what you'd do is blur out the faces or pixelate them, but the directors wanted to make it more emotive for the audience, so they replaced the faces with actors' faces. Now, again, was technically possible before. You could have, spent a mega VFX budget to replace the faces and, track and animate and build models. But let's be honest, no one would do that for a documentary. But because of machine learning and face swap technology, that was impossible before, and now it's been done. And from everything you read, it sounds like an amazing feat.
Cool, thank you. So Vlad, what do you think machine learning will do in terms of being able to improve workflows? How can these new technologies help us as an industry to work faster and to get more work done?
Well, as an example, what we built at Techdashville is on top of the templates, and we control the results. We can do work like routine work, like identify markers, pull decay, do color corrections, and many other things. We kind of see the possibility of controlling software and mimicking human actions, like on an amount of shots, because that's how we work right now. Nowadays, you have like one shot, hero shot, and something connected to that. You need to process it. That's the business how it's running, and that's where the machine learning is great, because if you set up templates, you can run through quite a lot of things to automate. I don't want to open lots of business cases here because we're building quite a lot of things after just 3.5 years of heavy research and development. We put it to this: we see the possibilities. It's a lot. They're endless at the moment, but they're all concentrated about how to help artists and production teams to push through the amount of shots with a good quality. And I think first what's possible is to quickly like go through time deliveries, which are some very time consuming as well tasks. And we don't really need a lot of final quality there. That's what machine learning can do today already, and save enormous amount of human hours on this routine. And because, I mean, if you think about the consequences of freeing up time, you can spend this time on final image or do something else at the same amount of time. Like I showed in a video, it was live recording of 10 minutes, and I pulled decay, removed markers from shots, and did some other work. I'm not saying we need to work crazy like fast, but I'm saying that lots of things in the future will be in the hands of machine learning and just supporting artists with amount of work to be done. The creativity stays with them. Even like I was testing one of the guns and clip eye connected it with Nuke and kind of narrow filter, doing some crazy strange things. But it's like talking about impossible. We can create something new. We can create absolutely new environments which never been before, which will be weird. As long as we can give it a shape and describe it in a 3D space, that can open something incredible.
Mm-hmm. I mean, I can, as Ben mentioned, the amount of work that's coming in is only increasing, and finding artists to fill those seats is becoming more and more of a challenge. So anything that we can do to speed up the workflows and make it easier to get the work done, and more importantly, from an artist perspective, allow us to concentrate on the really creative stuff, I think is a great thing. So this is really exciting. What kind of problems are there that machine learning is particularly suited to? What is it really good at solving?
Repetitive, I mean, finding some patterns and all these repetitive things, right? And if you have any kind of data, you can get some knowledge from that and apply to your routine with lots of different ways of doing it. It can, I don't want to open it, but we can do quite a lot of things where humans don't need to think about these boring things and concentrate only on creativity. Even like when I was using my tools, for example, for one of the first presentations where I was recorded myself, I used all my tools and I didn't spend a second on any technical things. I was thinking about how to deliver the message and how to explain it better and what it should look like as a final product, rather than, oh God, I need to do something with this. No, I don't. It works for me. When we will turn on tracking properly, that will be incredible. I mean, you can just do endless amounts of takes and approaches and tries and check it right away if it all works for you, and then use it for final.
Mm-hmm. Okay, cool. So you spoke if machine learning is particularly well suited to those kind of repetitive data processing type tasks. Do you think where's machine learning's impacts going to be seen the greatest in the visual effects industry? Is it going to be in the pictures, in the pixels that we see on screen, or are we going to get more of a benefit, do you think, from the kind of improvements we can make to the infrastructure behind the scenes, the things that no audience member sees but will really benefit us as an industry?
I think it's going to be both, honestly. I think, yeah, it's going to be seen in pictures from the things like face swap, the matting effects like that. But it is also going to speed up the scale of things. So you're going to be able to, you know, tag loads of shots and, you know, batch them in a way that you probably wouldn't be able to do before, or you would be able to do, but someone would have had to go through and manually go through that rigmarole. And then I think it's probably going to also be seen in speeding up workflows generally, just, you know, whether that's, you know, in the node graph, reducing the number of clicks that the artist needs to use to get from A to B.
Mm-hmm.
I agree. It's both, and in terms of like whatever the image manipulations, right, through neural networks, it's one thing. I believe that something new will just happen unexpectedly, and just because it's evolution of technologies, and someone will put things together to create unbelievable things what we even can't think about right now today. I'm sure about that.
Yeah, no, it's very interesting. I'm really excited to see. Obviously, the stuff Vlad's doing and the stuff that the artificial intelligence research team is doing. It's really interesting. But I think there's going to be a lot of exciting things that come out of all the different facilities as they try and solve their specific problems. That brings me on to a question about data, and obviously, machine learning is data driven. We've established this, and it requires large quantities of data in order to train your networks. You run into all kinds of problems trying to create general algorithms if you don't provide it with enough data. So do you think it's the biggest visual effects houses which have the most data available to them that will really see the benefits of machine learning? They will be able to leverage it most effectively?
So I think the first thing, the benefits of machine learning, if we're talking about inference, the inference side of it, then actually it's kind of the same however much data you have. Then if we're talking about training, well, that was what we used to think originally, you needed tons of data. But with copycat, we kind of showed that actually there's this use case where you can train really specific things and you don't really need much more than the shot that you're already working on. So that's one aspect. If we're talking about the sort of pre-trained tools and, you know, the generalized tools, then I think the first thing I'd say is it's probably our jobs as developers to make sure that our tools are useful for everyone, whether they're in a big facility or a small facility. But beyond that, I'm actually quite optimistic that there is going to be a lot more sharing of data for the good of humanity. Even if you look at that, recently I saw that the ASWF had released like an open asset repository, and there were some data sets there from some really big players. So, you know, hopefully people are going to, I think there's maybe a culture will develop of sharing a lot of data sets. Yeah.
Well, there are lots of other ways to deal with data and algorithms, and it really depends on, like, okay, you can just throw resources and throw data and do one thing. You can be smart and accurate with it, and it will give you the same result. It's just a matter of time, maybe. But there's different approaches. For example, on our end, we build quite a lot of automations to actually drive our automations as a tools. So on backend, it's lots of things been written just to deal with that as well.
Mm-hmm. So do you think there's things that smaller VFX facilities could do kind of today or in the near future to really help them get the most out of the data that they have, and to really,
well, they can use our tools. They can use our tools already and start saving time and lots of human hours on routine work. So it will be happening. I'm pretty sure this is like what is a blue ocean at the moment, right? What they call it. It's early days. We'll see more examples of that, and it will balance itself. I don't think it will be like heavenly, like just large facilities. It will be balanced.
Yeah, and also the stuff, the inference changes we're making in 13.1, that's going to open up a lot of models that come from research and academia that people can use, depending on the licenses, of course. But there's going to be a lot there.
No, that makes a lot of sense. There's a lot of people in this area doing a lot of really interesting things, and hopefully as an industry we can leverage the people who are making the tools and leverage the learnings from academia and use all of this to elevate the industry and to solve the really interesting problems that we're trying to solve today.
Yeah, I think also there's when it comes to sharing data, there's probably a couple of problems. And the biggest one is there's a lot of copyright issues around it, but there's also a lot of work going on with anonymization of data. So I'm not, I'll be honest, I'm not an expert on it, but the idea is generally that people will be able to at least share weights that they've trained with, and that will obscure the data that it was trained on. And so people might feel more comfortable sharing at least trained weights on networks, which will help.
Yeah. So to that point, you get the weights and you don't entirely know what the data is. I think one of the big challenges with machine learning generally is that it's kind of a bit of a black box. Data goes in, something comes out. You don't have a huge amount of control over what happens in the middle, and often magic can happen in the middle. So that's a trade-off that's worth it. But how do you think this kind of new paradigm, where we get these outputs that we don't entirely know how we got, or we can't always exactly reproduce, how will that change the industry?
So I think if you're talking about, I guess where you're probably thinking a lot of some of the current things where you get something and it's a black box and it's not exactly what you wanted. And I think if you're looking at tools like that, then they probably sit alongside other tools and workflows, and maybe they would augment stuff and speed you up in certain circumstances. But I think there are other ways of looking at the machine learning stuff, which is not just this black box that is uncontrollable. So if you look at, say, the work we're doing with Smart Roto, the idea is that you're not actually disturbing the artist's workflow at all. It's the same basic workflow. You're just trying to speed it up. So, they still create their shapes in the same places. It's just that they have to do less keyframes in between. So in that example, if the network doesn't do exactly what you want, you can still tweak your rotor in the same way that you would have anyway. It's just you'll have to do it less. And so, you're going faster.
Well, I also think that it really depends on the task, but when technology will be giving you exactly what you want, you don't really need to think about what's going on inside, right? I mean, it's just going to take a time. But at Techdashville, we split all these things. So basically, I call it like we're not baking a cake. All ingredients are independent nodes, and the rest of the nodes are the same. Nuke is super powerful image processing tool itself. And leaving that and just saying, oh, we're going to do everything in machine learning, I don't see the point of doing it. Nuke is powerful. And what we do is just on top of it, we just put automations with every individual control and slider, and you can do iterations and things. So I think it really depends on what kind of branch of development is going, and it's either style transfers or it's data analysis and dealing with different approaches and ways.
So do you see that this is where the field is headed, is more to giving more control and being able to provide that rather than just an out-of-the-box solution long term?
As a compositing supervisor and compositor, I love control, because if I'll be asked like to change something and I like, oh, I can just keep pressing the button and it's not giving me what I want. It's like, and I can't change it. I have to either repaint it or do lots of manual work. Because, you know, like another important thing to think about automations is to control these results. We can generate lots of data. Enormous amount of data can be generated automatically. Do you need it? Because someone will need to review that. There's a whole process of actually quality controls and things like closing loops of automations that they are fully autonomously giving you exactly what you want. That's gonna take time to figure out. We know what we want to bring in this case, but again, if machine learning gives you exactly what you want and return your results only which are matching to your expectations, that's one kind of way. If you just like pressing buttons and randomly trying to get it from amount of whatever train sets, that's another kind of style of working and approach to automation. But automation must be under control, otherwise, well, Terminator 2 and Matrix and all these things. I mean, in a longer scale, but quality and space and management, yeah.
I feel like the ability to control the output of the machine learning is actually probably quite specific to our industry.
Mm-hmm.
So if you look at consumer applications, people don't really want the control, or they wouldn't know what to do with it necessarily. Like trying to tag face in Facebook, you want it to happen automatically. You don't. Okay. Maybe that's a bad example. If it's the wrong tag, you do want to be able to control it. But if you're doing a Google reverse image search, you don't want to start having to train your network. Your user isn't necessarily tech savvy, whereas visual effects is just a completely different, industry. People are amazingly tech savvy. We have, big computers. We know what we're doing. So, people definitely want to keep the control.
Yeah, our problem set is different to the typical use case for machine learning, and this will have an effect on the ability to adopt it. But I mean, I think it is coming, and it's as you're proving, it's coming in a big way. Technical question. So machine learning is perceived to require a lot of GPU compute. That seems to be the way that it's going. Most render farms to date, not all, but the majority of render farms are CPU based. Is machine learning going to change that? Are we going to have to build or extend our render farms to have a lot of GPU compute as well?
I mean, look, there is no doubt that that machine learning does run quicker on GPUs than CPUs. I mean, it's like an order of magnitude quicker. That said, from what we've seen so far, at least on small data sets, distributed training doesn't work that amazingly. So, in that sense, a GPU render farm wouldn't be such an advantage for training, at least. For inference time, yeah, it would, but by the same account, if you're trying to, go through 1,000 frames on 1,000 CPUs, okay, it may take a minute per node, but that's probably not a big problem if you're getting 1,000 frames done in a minute. It's like watching paint dry a little bit on the desktop, but yeah. Like I said, I can imagine there will be GPU render farms.
Yeah.
Well, again, like in our case, I would say that we were building it for current today use, and everything what's been presented today, and I'm showing on our YouTube channel, is running on CPU. We balancing this. That's a requirement for us as well when we choose to try or use technology for like specific needs or create our proprietary algorithms and train sets and stuff. So it's a balance. It's really a balance. Our tasks are small, they're simple, they're easy, but in the end, they do complete task of removing markers. So it's a matter of like, what are we doing with it? What do we need to do with this? And we know that, for example, if for enterprise, we're turning on GPU support, absolutely. And in one company, will be enough of a one system from us, for example, to process all requests from the studio for the things our automations can do. And we will turn it for cloud users as well. It will give like speed of 10 times faster than it was now. I don't think, like in our case, do we really need that it that fast for the post-production? Real-time implementations, it's another question. But how fast do you need to get it? I mean, this is the balance. That's what needs to be established. And we just don't know the numbers. Like, we don't know how fast we can do and how fast we need to do. Specifically, not as fast as possible, but specifically some certain speed, right? And something need to drive expectations and demands, I think.
Cool. So did you have something to add there?
Yeah, I was just going to say, the thing is as well that speed things run at generally depends on the network size. So, if there are algorithms certainly that will work fast on a CPU. As you probably see all the time, running Zoom when if you don't have a good GPU, it can still do background segmentation at times. So it's not accurate. So it kind of depends what you want.
Mm-hmm.
But yeah.
So there's always this trade-off between resources and quality and time. It's the challenge that we always face in VFX. All right, one last question, and then we'll go to some of the questions in the Q&A. I'm not going to hold you to this. I won't come back and check. But if you were to make a prediction about how machine learning is going to change VFX over the next 5 years, if we all come back in 5 years' time, what do you expect will be the state of the industry, and how will machine learning have impacted that?
Well, on the whole, I think people are just going to be working faster at larger scales, going through hundreds of shots in the time it would take them to do, tens before. I think there's going to be cheaper VFX, and I think there's going to be way more VFX because of that. I think one of the most exciting things, I think we're going to see more of true director's visions at times. So, it's going to enable people to tell stories they wouldn't have been able to tell before. Whether it's just the ability to do time jumps and flashbacks that would have been impossible, or even if it's just, on a more technical level, like recovering the shot that would have been thrown away because the focus puller missed their mark, or reframing a shot after the event, or even getting the best take possible because you combined bits of other takes. So, yeah. It's exciting.
I think that disciplines will change a little bit. Some of them will just merge, and because automations will be doing some work for those, not departments, but for some parts of the work. So, and people will be free up from that, and they will be doing other works. And it's actually will impact every department and every stage, I believe, in a way how I'm just saying, not in a bad way it will impact, it will transform it. We see all the CGraph papers and lots of papers, animation, tracking systems and layouts, and Facebook research showed like world position path generation, incredible. So, the depth estimations and stuff. So it will transform it to, we will be doing it in a slightly different way, faster for sure. And I think one artist will be kind of a lead of a group of sequence and machine learning algorithms, dealing with them, producing amount what can be done now with a big teams of human professionals.
Cool. All right. Thank you both. Shall we go to some of the questions in the chat?
Sure.
All right. So starting at the most popular question is, Ben mentioned the possibility of sharing data sets. Is there a plan to have a platform where people can share trained inference nodes by the Foundry, or even get some provided examples for general tasks like Roto, with examples of results maybe?
So actually, I imagined it would always be on Nukepedia. So the CAP files, yeah, people are able to share them. So I'm guessing Nukepedia is probably the best platform for that.
Yeah, I would agree with that.
So Attila, get everyone started. Put one up there, train something, and show everyone. And if you'd say get some for general tasks, well, actually, so the upscale and deblur networks that are provided as starting points in Copycat, I mean, they are essentially that. They're generalized tasks for trained with a similar network to Copycat.
Cool, thank you. So another question is, if an artist would like to pursue this field of machine learning and AI for VFX, where should they start?
Google. Google type machine learning. Jesus, my Google turned on. Machine learning GitHub. Go there and just identify what you want to do, what task you want to solve with machine learning, and just read about that. It's an enormous amount of information, like in open source communities, and all these arcs with papers, and like incredible.
I'm also going to suggest Andrew Glassman's SIGGRAPH talk from a few years ago. It's a course. It's about 3 hours long, but it's such a great starting point. Kind of summarizes everything, at least the broad strokes in 3 hours. It's fantastic.
I also think it's worth mentioning Copycat is an artist-friendly way of beginning to understand machine learning, providing ground truths and inputs and passing that through a network and training it, and just without having to write any code or understand under the hood what it's doing, just understanding the principles of training and getting results and then applying those results to something else. I think Copycat is a really good starting point for beginning to understand machine learning.
Yeah, I just didn't want to sound like a scratched record there. And also,
well,
if you're going down the Copycat road as well, there's some wonderful tutorials as well on the Foundry learning page to get you started with that.
Cool, thank you. So, question for you, Vlad. Are your tools available in a learning edition or some kind of trial?
We're providing the 2 weeks trial before you decided to buy and subscribe. It's enough time to not only test it, but to do some work as well.
Cool, thank you.
But maybe was it a question about like Nuke Indie? I need to check about Nuke Indie.
Yes, there was a question.
Right, yeah.
Do your tools work in Nuke Indie?
I didn't test them. I don't know. We can, David, Ben, we can just check like whatever the limitations there and offline basically. And
yeah, we can. We should definitely touch base on this, because if they don't work, it would be great to enable them.
Mm-hmm. Mm-hmm.
Cool, thank you. Ben, there was a question about Copycat support on OS X.
Yeah, so Copycat does work on OS X. It is, though, CPU only. It's actually, it trains quicker than you'd expect for CPU. I said, an order of magnitude slower. That's more for inference, actually. It is slower, for sure. So I guess what you want to know is, like, when will it work just as fast on OS X? I can't give you a concrete answer to that. All I can say is, it's something we are concerned with and want to get working. It's slightly reliant on third parties at this stage. But yeah, someday I really hope and confident that it will work fully on OS X.
We are talking with Apple about this as well, and it's something that they're keen to make happen and we're keen to make happen. So we can't give you a definitive answer, unfortunately, but we do want to solve this. Okay, what else have we got? I think there's another one for Vlad. The alpha extractor node can do all the mattes like core, detail, and gray matte. Can it do all in a single node?
Yeah, I've seen this question. I really didn't understand the last part. So basically, if I understand you correct, if you need to create a hard mat and core mat and soft mat, you can do different type of training to the same shot. So you can make a hard key train set, you can make a soft key and then combine them. Whatever you put into the training and you have similar looking shots, you can just tweak to the result you want, and they all will be, the machine learning, our algorithm will try to bring you the same result. I hope I answered the question.
Cool. All right. Thank you. I think that is all of the questions that we have. So any last words from Vlad or Ben before we wrap this up?
Well, I just want to say thank you very much, and join us with the automations and start saving time today, because when you free up time from routine, you see more things, you see new things which you didn't have time to look at before. And that's what at least our automations are about, is to help you to be creative. It's really enjoyable when you're working with image rather than dealing with technical problems or routine work.
Yeah.
And it's efficient, economically too.
I can't follow up such great philosophy, to be honest. I'll just say thank you all for listening.
All right. Well, thank you both for a great chat. I think it's been really good. Thank you to everybody who's taken the time to attend this webinar. I'm going to hand over to Joyce now to wrap us up.
Yeah, perfect. I was literally going to say the same thing. Thank you everyone for joining. Thank you, Vlad, David, and Ben again for sharing all of your insights and answering all the great questions. Hope you had a good time in the webinar as well. Thank you to our audience wherever you are in the world. As I said, this webinar is recorded and will be available as on demand, as you can watch in your own time. And stay safe wherever you are, and take care, and see you all soon again in another virtual event series. Take care. Bye-bye.
Bye-bye.
Bye.